In this video, we are going to start marching our way across the toolbar that sits across the scene view at the top of your viewport. The first part of it shows you the various draw modes that you can put your viewport in. Now, if we click on this drop down, again, it's kind of up in the upper left-hand corner of your interface, right along the top of your viewport, you'll see that we have 5 different draw modes that we could access. And by default, this is already set to textured. Now, textured does exactly what you see. It shows all of the objects in your view with all of their texturing, and it looks great, and it's fun to look at. But if we come down, we can set this to wireframe. This shows us the polygonal wireframe that makes up our level.
These are really good if you switch over to an orthographic view.
Well, let's just go ahead and do that.
And pull back
you have
out.
to really pull back.
Yeah.
There we go.
So now it's a good way to get a elevation view and be able to see through some of this terrain to see where stuff is.
That's right. Now, let's go ahead and jump back over to perspective. Now, our next draw mode from wireframe is texture and wireframe, or text wire. Now, this shows us the best of both worlds. We see the textured surfaces we saw a second ago, and we see wireframes drawn on top of that. So we get all of the polygonal information we need, and we can still see our textures and all of the lighting information that we had as well. Now, down from this, we have render paths. Now, what this is doing is color coding your entire level. Now, how does this color coding actually work? Lee?
Well, the color coding is based off of render paths, which is a discussion we'll have in a future video, but basically it is what path the engine decides to draw your objects on the screen.
Or the kind of lighting it's using on this particular object, yeah?
Well, it's not so much all the lighting. It's actually a process of how it applies the shaders and textures, and your lighting and shadows. And there's 3 different ways that it can be approached. What this is trying to show you is what parts of your scene are using deferred lighting. Those are the ones that are going to be in green. Deferred is the most advanced of the rendering modes, and it is only available in Pro. Unity.
Right, so if you're using Unity Basic, you probably won't see anything in green whatsoever.
I think you might still see it, you just can't.
Oh, you can't actually utilize it?
Right.
Gotcha.
But I can't validate without the standard version.
Right now we're using Unity Pro.
Right. Now, the next color that we don't have anything right now showing up would be yellow, and that would be elements that are using the forward rendering path to be drawn. And the third, which is red, is what is being drawn in vertex mode, or vertex rendering path. And this is just basically a way that you can get an overview of what is being drawn using what in your scene.
Right. It's showing you how what light calculations are being used for each object. So again, green is going to be for deferred lighting. Yellow is going to be for forward rendering. Well, it's not deferred lighting; it's deferred rendering. That's technically what that's called. So green is deferred rendering. Yellow is going to be for forward rendering, which again we don't have any assets in our level to show that off. And then we have red, which is just for standard vertex lit.
Correct.
So let's jump over to light map resolution. Now, what's this going to do for us?
All right, light map resolution is a way to preview how much texture space is going to be allocated for your light maps if you're utilizing the Beast light map engine that is inside of Unity now. What it is doing is giving you a visual representation of how many texels are being allocated to the light map. A texel.
Whoa, what's a texel? A
texel is actually
It's a texture pixel. That's where they came up with the name, actually.
It's kind of an equation, and what it does is you take one Unity unit, and a resolution of 50 texels would mean that one meter or one unit in Unity is using 50 pixels to be represented. You can adjust this number in the settings, so if you need more resolution, you can adjust it to, say, a resolution of 100, which would mean you would have 100 pixels being allocated for every one unit inside of Unity.
Now, if we take all of that great, cool, awesome technical stuff that Lee just said, and we boil it down to some really simple phrasing, basically this checkerboard texture you see is going to show you the resolution of your light maps, such that the bigger they are, the more spread out your resolution is going to be. So consider how big the checkers are here on the side of our terrain versus how tiny they are if we come over here to this polygon model. So there's a lot tighter resolution, which means any pre-baked shadows and whatnot will likely appear a lot crisper, a lot sharper here on the polygon model than they do when stretched across the terrain.
Correct.
And that's what it's here to help you visualize, is before you even try rendering out your shadows and baking all that stuff out, you can already get a quick idea of where the shadows will be sharp versus where they're going to be soft.
Exactly.
So that is a quick look at all of the different draw modes we have access to. One more time, we have textured, which is kind of the standard you'll be using 99% of the time. We have wireframe to show you all of the pixel information. We have text wire, again, a combination of texture and wireframe. We have render paths showing you the kind of the render modes. I don't want to use the word render modes because that's inaccurate. The types of render calculations being used to draw each particular object in your scene, and it's color coded. So it's, anything that is using deferred rendering is going to be green. Anything using forward rendering is going to be yellow, which again we don't have. And then anything in red is using your standard vertex lit.
Right. An example of something that would show up yellow is a semi-transparent object, because if you read the specs on rendering paths, deferred lighting cannot handle semi-transparent objects. So those are actually done with not vertex, sorry, my bad, is done with forward rendering.
Mm-hmm. Now, and the final one that we covered was light map resolution, which again is going to show you the crispness of any baked out shadows that you might have by giving you a graphical representation in the form of these checkerboard patterns. And again, you can see how large those are as they're stretched across the terrain and how tight they are on these polygonal models. So that covers all of the draw modes, which will wrap up this video. Thanks a lot.